Hello, welcome to my series on computer science and computer science integration pedagogies. My name is Yu Hongsun. I'm one of the MLTI 2.0 ambassadors. My job is to work closely with the Moodle digital learning specialists and the other MLTI 2.0 ambassadors to provide instructional technology coaching, create and deliver professional learning. This is me in my Bitmoji. I'm very excited that you could join me in exploring some of the effective pedagogies in teaching computer science and integrating computer technology into K-12 curriculum. Over the past decades, there has been an increasing research on computer science and computer science integration pedagogies in K-12 education. Data shows that certain teaching methods are more effective than others for computer science and computer science integration. The theories will explore the popular pedagogies for computer science and computer science integration, such as computational thinking, contextualized learning, collaborative learning, and learning away from the computer. The series will use examples from the teachers of computer science and other disciplines and discuss which teaching methods and pedagogical approaches are effectively used in the classroom and how the teaching methods support the learning processes and prepare students for the 21st century job market. Here are the topics. Topic 1. Computational thinking skills development. Topic 2. Engaging students through contextualized learning. Topic 3. Building critical thinking and problem-solving skills through collaborative learning. Topic 4. Cultivating computer science and computational thinking skills by teaching away from the computer. Today's topic is engaging students through contextualized learning. It will cover what is contextualized learning, why use contextualized learning approach, what are contextualized learning activities and tools in computer science classrooms, how can we implement contextualized learning to engage students in computer science, how does the use of contextualized learning tools, robots, and animation affect student performance? What are the benefits of contextualized learning? As I mentioned in my first video, America has made a substantial progress in promoting computer science and computational thinking in K-12 education. However, we still have a long way to go. Many American students still think of computer science as a difficult, tedious, boring, and nerdy subject. In order to change that image, many computer science educators have experimented with different teaching methods and strategies to teach computer science and build students' computational thinking skills in a fun and meaningful way. In the past decades, many tools and teaching materials have been introduced. For example, instead of writing long lines of codes, in text-based programming, students can learn about computer science by creating an animation to tell a story in block-based programming, or by programming a robot to follow instructions. In this video, I'm going to share my experience and perspective how to teach computer science and build students' computational thinking skills through contextualized learning. Simply put, contextualized learning is a method that enables students to apply for new knowledge and skills to real-life situations. According to Robert Burns and Patricia Erickson, contextualized learning is a conception of teaching and learning that helps teachers relate subject content to a real-world situation and motivate students to make connections between knowledge and its applications to their lives as family members, citizens, and workers. There's no doubt that contextualized learning can tremendously boost learning results. In the past decades, there has been an increased interest in contextualized learning activities in computer science education. Putting learning in context can make the learning experience more engaging and fun. When students can connect learning experience to real world and find it relevant, they would feel less difficult to apply new concepts to unfamiliar situations. This would dramatically increase students' motivation to learn. That is why contextualized learning and contextualized assessment are frequently used in computer science education. According to Dr. Burns and Patricia Erickson, by using contextualized learning approaches, the learning draws on real-world tasks, situations, and problems. In doing so, learning and assessment can authentically reflect work of the real world and show how students could transfer their knowledge and skills to the world. Why use contextualized learning approach? Constructivist learning theory. Pedagogies, or teaching methods, play an important role in learning, while pedagogical theories provide reasons for why learning with a certain teaching method works better than others. Contextualized learning is aligned with the constructivist learning theory. Learning takes place when teachers are able to present information in such a way that students are able to construct meaning based on their own experiences. Approaches for implementing contextualized learning include problem-based learning, collaborative learning, and project-based learning. Based on Andrea Zandler's article, Teaching Methods for Computer Science Education in the Context of Significant Learning Theories, and Professor George Hines' article, Constructivist Learning Theory. Learning is contextual. Students construct knowledge from their lives. The instructional design is an integration of learning content in situation. The principle of teaching is the co-construction of knowledge with students. Teachers' role is to teach students self-responsible and social learning processes. Students' role is to co-construct knowledge from others. Peers' role is to participate in the process of knowledge construction. Learning is physical. Learning happens in physical actions, hands-on experience. Learning is mental. Successful learning takes place in the context of self-effective learning. Based on the constructivist learning theory, many computer science educators have experimented with contextualized learning in computer science classes in the past decades. They believe that to incorporate the concepts in meaningful activities and in a scenario is crucial to increase students' understanding and to make the concepts more relevant and relatable. They have used constructivist learning theory as guidance and contextualized learning, such as problem-based learning and project-based learning, as approaches to design and create educational programs for students to learn computer science. Animations, games, and robotics are particularly experimented in computer science classes to create a contextualized learning environment to raise students' motivation, increase their participation, and enhance their performance. Another contextualized learning tool that has gained significant attention recently is the use of educational robots. The computer science educators believe That is the nature of robots as physical objects allows students to see the execution of their codes immediately, and robots are considered a useful and learning tool according to Bach in 2008, Chen and Mahadev in 2012. In the past decades, apps, programs, and educational robots have sprung up like mushrooms to help students learn coding, programming, and computer science concepts. For example, First Lego League, Scratch, Switch Playground, Vex Robotics, Sphero Robot, Funch Robot, Peapod, to name just a few. They are used in the classroom at all levels. According to David Benham in 2016, computer science has become a medium for storytelling, offering exciting pathways for students to build a personal identity and conquer the powerful technology. Those approaches and tools changed the image of computer science as difficult, tedious, boring, disconnected, or nerdy. Those strategies and tools are frequently used in computer science education to implement a contextualized learning environment. They have been proven to be effective in teaching students computer science concepts and develop their computational thinking skills. With those visual programming tools and robotics strategies, students can write programs and immediately observe the execution. I used the First Lego League, Vex Robotics, and Scratch to engage students in middle school and high school to learn computer science and computational thinking concepts. In this video, I'm going to focus on my experience of how I used the First Lego League to engage my students in a contextualized learning environment to learn computer science and computational thinking concepts. The First Lego League is an international competition organized by FIRST for elementary and middle school students. According to Dean and Q, the creator and owner of the First Lego League, the goal of First Lego League is to introduce science, technology, engineering, and math to children ages 4 to 16 through fun, exciting hands-on learning. Students gain real-world problem-solving experience through a guided global robotics program, helping students and teachers build a better future together. Each year in August, First Lego League participants are introduced to a real-world challenge for teams to focus and research on. The robotics part of the competition involves designing and programming robots to complete tasks. The students work out a solution to a problem related to the theme, which changes every year, and then meet for tournaments at different levels to compete, share their knowledge, compare ideas, and display their robots. In February 2002, I began to teach students computer literacy at Pownell Elementary School. In order to motivate my students to be interested in computer science and develop their computer science and computational thinking skills, I started an after-school robotics club and encouraged my students to participate in the First Lego League competition. I believe that robotics can be an effective way to introduce computational thinking because it requires students to systematically process tasks, develop algorithms, and write codes to perform a robot. To my surprise, almost all of my middle school students, over 30 out of 40 students, joined the club. The competition consisted of two parts: research and robotics. I invited an English teacher and a music teacher to help the students with the research, while I helped students design, build, test, and program robots using LEGO robotics units. To prepare students to participate in the first LEGO League competition, there are many things to do within 3 months, from middle of September to January. After studying the challenge, I plan to implement contextualized learning method because, according to Burns and Erickson, approaches for implement contextualized learning include problem-based learning, cooperative learning, project-based learning. That is what I need. I used their strategies to design my approaches to engage students in their learning. I started by listing a lot of questions. How to plan lessons appropriate for students. How to provide students with an environment that supports their learning. How to take into consideration the diversity of students. How to address the different levels of intelligence of students with different learning styles. How to facilitate, organize, support students' learning through authentic activities. How to assess students' performance and progress. The challenge of 2003 was Mission Mars. Students were required to research on NASA's Mission Mars, design and build an obstacle course with different challenges. These challenges were completed by a robot. Based on students' research on Mission Mars with the help of other teachers, I further incorporated the contextualized learning strategy into the 6 first LEGO League steps to guide students to successfully build a programmable robot. Step 1. Analyze the missions and develop a strategy. I engaged students in real-world problems by helping them study the Mission Mars, which was revolved around the NASA missions to Mars with the Spirit and Opportunity rovers. I helped them get familiar with the challenge setting and materials, then engaged them to make a plan with their planning skills. Step 2. Build and program a robot to meet that. I encourage students to use inquiry, critical thinking, and problem-solving skills as they designed and created the robot by providing them with a comfortable environment for inspiration and helping them put materials in right place. Step 3. Test the robot and make improvements. I helped students learn content-specific skills and knowledge in contexts as they worked on their project, such as how to use light sensors, touch sensors, code interface, how to trace bugs and debug them. Step 4. Develop solutions to individual missions. I optimized each student's strength by assigning each student a different role and responsibility. I encouraged students to learn and practice their interpersonal skills as they worked in teams. Example, I created different job titles for them, such as team leader, designer, builder, researcher, debugger, etc. Step 5. Test out code and robot. I encourage students to apply their evaluation skills to see whether their methods and strategies work. If not, find out the issues, modify their design or debug the bugs. Step 6. Iterate as needed. When their robot was not working well, I helped students to fix the problem. Contextualized learning method is student-centered. Instead of passively receiving knowledge from teachers, students actively construct knowledge from the situation. By implementing contextualized learning method in first Lego League project, I served as a facilitator, a coach, a role model, and a content specialist. For 3 months, the middle school students researched, planned, designed, built robot, programmed the robot, tested the robot, troubleshoot problems. They learned how to program a robot to make it follow instructions, how to make good use of light sensor, touch sensor, to manipulate their robot's movement, and how to use the IR interface and enable several Rex bricks to communicate. They learned that the robot must be programmed step by step in a precise order in order for the robot to follow instructions and perform the task as it was instructed. The students build their computational thinking skills to think critically when they debugged and solved problems through the project. Their hard work paid off. My students participated in the main state first Lego League competition and won first place in 2003. Students were so inspired after they won the first place in the main state robotics competition. They were so proud of their 3 months dedication and hard work. Those are what they said about their learning experience from the project. They said they not only learned engineering and computer skills, such as robotics design and construction, coding, programming, and developing processes. They also understood what it took to be successful. They learned to take responsibilities for what they were assigned to do and try to do it well. They learned trial and error and never gave up. They learned to handle the pressure with limited time. They learned to communicate and collaborate with one another and helped each other. They knew that success was team efforts. They learned to think critically about their experiences. When students came back to school, they did a presentation to showcase their success to the panel community. The whole community were thrilled. The next year, the students participated in the first Lego competition again and won 4th place in the state tournament. Pownell Elementary School kept the robotics program, and the students kept shining in the state competition even though I left Pownell Elementary School in 2004. At Noble High School, I continue to use robotics as one of the methods to teach students computer science and computational thinking concepts. I took students to compete in the Boston University robotics competition for high school students. Students loved it. Later, I had my principal purchase 2 sets of VEX robotics units. I integrated the robotics into my Introduction to Programming Language class. I designed the class differently for high school students. I introduced the robotics in the last month of the semester. The purpose was for students to strengthen the computer science knowledge and skills they learned through hands-on experience and also tested their skills. I used the same challenge as that of the Boston University robotics competition for the high school students. The challenge was for the robot to climb up and down a 16-feet-long bridge, 2 8-feet-long ramps on both sides. The top is a 2-feet-long platform. I had my husband build the bridge. The challenge was for the robot to climb the ramp, lock down a flag on top, and then climb down the ramp on the other side in 20 seconds. I divided the students into 2 groups and let them compete against each other. Students had a lot of fun designing, building, and programming their robots. From my middle school and high school robotics programs, we can see that contextualized learning with robotics makes learning fun and relevant. It substantially engages and motivates students to learn. It increases students' capabilities, confidence, and enthusiasm. When students witnessed their robot's performance, they were excited and felt encouraged to learn more and do better. It enhances interest in long-term goals and education. Pownal Elementary School made the Robotics Club a permanent program because students and parents insisted after they saw the learning results. Implementing contextualized learning with robotics leads students to have more positive view of computer science and STEM subjects. Students were more attentive to my computer classes. They thought computer science was fun. Students' experience of first LEGO League robotics and the Boston University robotics competition increases students' motivation and interest in computer science and STEM careers. I don't have any data for middle schoolers, but most of my high school students took more computer classes, and many of them majored in computer science or computer-related disciplines in colleges. Some joined the workforce as web designers, computer programmers, or IT engineers. The hands-on experience of first LEGO League program and robotics integration improves students' learning in computer science and STEM. Before the first LEGO League project or Boston University robotics competition, a robot was just a toy for students, but at the end of the project, they understood that robots were complicated and programmable machines. They could write instructions for the robots to follow. The more they learned, the more they could program robots to do things for us human beings. In addition to robotics, I also experimented animation and games in teaching computer science skills. I tried Scratch because many computer science teachers recommended. Scratch is a web-based and block-based visual programming language for students ages 8 through 16. It was created and developed by the MIT Medium Lab. Because of its simple visual interface, it has been a popular tool for computer science teachers to teach computer science skills and for teachers of other subjects to build students' computational thinking competence. Teachers can use Scratch to develop students' computational thinking and problem-solving skills, inspire imagination, and enhance creativity. Students can use Scratch programming language to create digital stories, games, and animation. When they design and create Scratch projects, they build their computational thinking and communicative and collaborative skills. I began to use Scratch during the pandemic years because it was free and there are a lot of resources. I use it to teach students animation and programming. My approach is based on contextualized learning, and the activities are relevant and authentic to draw students' attention. After experimenting Scratch for a year, I found it was an effective tool to implement contextualized learning in computer science class to teach students computational thinking skills such as logical reasoning, pattern recognition, etc. Students learn computer science concepts such as events, variables, loops, controls, and apply those concepts to write codes and see the execution immediately, which tremendously increased students' interest and enthusiasm to learn computer science. Scratch makes learning programming concepts easier with visual interface and color-coded commands, and help students make smoother transition from block-based to text-based programming languages. My students sometimes went extra miles to do a project. Here is an example from one of my 9th grade students in my web animation and game design class. The project was for students to create a digital card. James created his own 3 backgrounds. He used the cat from the Scratch library, but drew his rocket and flag. He programmed the cat, rocket, and flag without any problems, but encountered some challenges of fireworks. He eventually figured out the fireworks all by himself. There are many benefits of using Scratch tool. It is a visual block-based programming language. It is free and easier to use. It builds students' computational thinking skills, improves motivation and engagement. It enhances students' problem-solving skills, encourages creativity, develops self-expression, and also promotes equity in computing. Animations, games, and robots are constructive and powerful tools to implement contextualized learning in computer science and computer science integration. Those tools allow students to think logically and solve problems systematically. Even younger students can be exposed to use these visual programming tools and robotics platforms to build their programming and computational thinking skills. According to Brenner and Resnick, by designing and building a robot, students are developing critical thinking skills. By programming the robot, students are building computational thinking ability such as decomposition, abstraction, algorithm, logical reasoning, pattern recognition, and evaluation. By testing how the robot's construction and programming commands interact with each other, students are enhancing problem-solving competence. By creating a sprite and designing the background in Scratch, students develop creative skills. By programming the sprite, students learn computer science concepts such as events, motion, loops, variables, and controls. By animating the sprite in a situation, students develop their computational thinking skills. According to Christina Chalmers, Scratch or any other visual block-based programming tools allow students to develop a better understanding about the world and about themselves as creators and designers rather than just consumers of technology. According to Christina Chalmers, learning to code, particularly with tangible systems such as robots, can positively impact students' ability to sequence correctly and debug or troubleshoot. Using easy-to-use visual programming tools enables students to develop simple algorithms as they drag and drop actions into coding sequences. Therefore, animation, games, and robotics are effective tools to implement contextualized learning to engaging students to learn computer science concepts and develop their computational thinking skills. Thank you for watching my video. My next topic will be building critical thinking and problem-solving skills through collaborative learning.